My name is Bonnie Fujiasco, and I serve as the Special Events Manager for the Alumni Association at the University of Wisconsin-Milwaukee. Good morning again. I am so pleased to welcome all of you to our Future Panther Academy event. Today wraps up our 8-week series. Can you believe it? We are on wow, I can't believe it. It's gone so fast. 8-week series called Stars Have Stories. And we've been doing this in partnership with the UWM Planetarium. Our host, Dr. Jean Creighton, is an astronomer, and since 2007, she has been the director of the planetarium at the University of Wisconsin-Milwaukee. And boy, do we have a special episode for you today. Dr. Jean was selected by NASA to be an Airborne Astronomy Ambassador, and she got to spend 20 hours in the stratosphere on SOFIA. Now, SOFIA is the largest moving observatory in the world. And guess what? Guess what, viewers? She's sharing that adventure with us today. We're going to take a little trip with Dr. Jean for our final episode. So strap in. It's going to be a blast. Following the program, I want you all to stick around because we're going to dig into the mailbag, and Dr. Jean is going to answer as many questions as she can that we just couldn't get to in some of our previous programs. So do stick around for that. So without further ado, I'm very excited to turn it over to Dr. Jean.
Thank you so much, Bonnie. This is a real pleasure to relive this wonderful adventure I had in the stratosphere. Let's explain a couple of things. First of all, the stratosphere is the level above the troposphere. So we are breathing, commercial airlines are in the troposphere, Mount Everest. SOFIA, the flight I was on, is in the stratosphere. So one layer up. That's where also military airplanes can be. All right, so let's consider our adventure. You might ask, how did I get selected to do this? And there are probably two reasons. Well, three, actually, three. First of all, I applied. I applied by the deadline. Showing up sometimes is half the battle. You're busy, and you make it happen. So that's something to consider for future adventures that you might have. The second reason is that I have done research in star formation using infrared observations, so I would understand the science kind of intuitively. The third reason is that because I direct a planetarium, I would be able to share this adventure really broadly, and NASA wanted some nice publicity for this project. So for all of these reasons, I was one of the people who got to go on this adventure. SOFIA stands for Stratospheric. Observatory is a word that we would use a telescope, right? So this is a large telescope. And infrared is one of the flavors of light that we can see. Our eyes can't see it, but you can think of it as heat. Infrared light is like heat. Now, please look on the picture of the left, on the left, and think about, is there anything wrong with this picture? Is there anything that makes you think, I would not want to be on that airplane? And I'm hoping you notice that the door is open. And it's true that if this was a commercial passenger airplane, you would not want to see a door open. This is an exception. Because we're flying so high at 45,000 feet, the air outside is can be 70 degrees below freezing. And obviously this is not a temperature that I would want to be sitting in, but there's a wall that separates us from the telescope. Infrared telescopes really benefit from being super cold. And that allows us, without having too many fancy instruments, we can keep the telescope really cold, and that helps us see what we're looking for. So that's why the door is open. It has to be that way. I must say that when I was chosen to be on SOFIA, I thought, I love the fact that it's called SOFIA, because if we had a daughter, she would be named Sophia. That is a Greek word that means wisdom. And that would be it. But we had 2 boys, so it turns out that we didn't need it. Let's check our next image. Now, a good question to ask is, so why do you need infrared light? Why can't you just take a picture with visible light? So this is Orion. Some of you have seen this before. Clearly, the blue lines are added, but this picture shows us what the stars look like in the direction of Orion in visible light. But it's quite different if we change our glasses to see in infrared. Let's do that. Ta-da! There it is, quite different. Now you can barely see any stars. What you see is the gas and dust that give birth to the stars. If you want to tell a whole story of how things come to be, just one kind of light often isn't enough in astronomy. You see a whole nother world if you can look with different glasses, and I hope that you see that here quite clearly. So if we're trying to figure out how stars are born, we need infrared light because it allows us to see clouds of gas and dust. Nice. We arrived a week before we were going to fly. This was in the spring of 2014. We were in a building that was named Dryden at that time, but was renamed shortly, well, around the time we were there to honor Armstrong. Notice I'm wearing a yellow inflatable jacket. Maybe some of you have been on an airplane. Remember when you sit down, they tell you, oh, you pull the red tab and it inflates, and don't do that before a flight attendant tells you. Well, I said, can I please be the one who pulls the tab? And I was allowed. So finally I got to wear the vest. Happily, we did not need it, but this was part of our training. We were also given like a survival kit that included this shortbread bar, and I kept it as a souvenir. Apparently it tastes a little bit like sawdust, so I didn't want to eat it. I wanted to keep it. Guess how many calories this has? 4,000. In principle, you could survive for 2 days on this one bar. Again, hopefully, happily, we did not need that, but it was nice to know that we had some supplies if we turned out to need to have an emergency landing. Okay, so on the day, this is a pre-flight meeting, and you might have heard adults, I mean, I'm assuming we have some adults with us who talk about meetings and their heart sinks and they think, oh, another meeting. But to me, this meeting was returning home. I used to work for NASA for 2 years before on an infrared satellite, and we had a meeting, at least one every day. It was as short and as focused as possible because we had a hard deadline. We had to get data up by 4:30, and if you didn't, then that was it. So it was so cool to have a meeting that was run by Kristen. I guess she had a career in the past as a high school teacher, and she kept that meeting moving. Nobody was allowed to speak unless they had to say something important, relevant to the flight of that day. 20 minutes, we were done. And I thought, yes, it really felt, okay, here we are, I'm back at NASA. People thought that we had to have a heroic shoot, so here it is. We're approaching the airplane. One, two. That was our little how to remind our safety procedures in the airplane. The thing that really made an impression for me was that you do not want to fire. You'll go to any length to avoid a fire entirely, and also to put it out as absolutely quickly as possible. Now, there were 26 people on the airplane. Oh, we liked it well enough that we're going to see it again. So this was our flight path. We left out of Vandenberg, out of just a little north of LA. And check out our flight path on the first day. We're going over British Columbia, Alberta, Manitoba, Saskatchewan. Now you might look at that and say, that looks pretty random, Dr. Jean. Why on earth do you have a path like that? The path is complicated. And in fact, it is programmed before we fly, but sometimes you need to make adjustments. So we had a person whose only job it was to make sure that the path was appropriate. So first of all, there are no-fly zones, especially on the western part of the US. And you would try and avoid those entirely if you could. There's also the issue of being where you can see the targets, because we had multiple observation areas that we needed to look at. So you want to make sure that you can see them from where you are. And the final point is that not all observations require the same quality of data. The higher you are, the less atmosphere you have to deal with, the better your observations. But you want to keep those to the very end so that you've burned some of your fuel, which weighs you down, and that you can get more easily at a higher altitude. So those were all the reasons that determined where we flew at any given time. This image is to remind me to tell you that this is not a commercial airplane, right? So they strip everything that's not necessary. Airplanes, even commercial airplanes can be pretty loud, but there's quite a bit of insulation to reduce the noise. Well, now all that's gone on SOFIA, so it's pretty loud. And if you had to talk to people just straight up, you'd be shouting all the time. So what we had was a system, an intercom basically, where you could speak through your microphone. This had an added bonus. You could eavesdrop on any conversation you wanted. You say, I want to know what the pilot is saying to the ground. I want to know what the flight director is saying to the telescope operator. Anything you could listen to, anything you were allowed to, you could. And that was a lot of fun because you felt like you were in the know, in the nitty gritty of any issues that we had on the flight. As I said, there were 26 people on the flight, and we had telescope operators, we had a flight director, we had software engineers, we had people who were specialists on various instruments, because SOFIA had more than one instrument, various scientists, engineers. As I said, we had 26 people overall, and I'll show you a movie that follows. But I want to explain something that you can see also in this image. I hope you see that blue kind of circle. That is the back of the telescope. And you can't see the telescope because there's that wall there that separates us from the telescope. And you might think, oh, that's because we want to make sure that the cold air stays with the telescope. But really, we have that protection for the telescope. We don't want any of our hair, any of our skin cells to make it dirty. So I think the next one is our movie. So before we start the movie, notice how at the back end, there seems to be what looks like a little closet, a cream colored closet. That is the counterweight. The telescope is so heavy that you need a counterbalance, and we don't want to have dead weight on the airplane. So those are some of the electronics to counterbalance the telescope. And the telescope is just a little bigger than the Hubble telescope. That's not the biggest telescope in the world. There's some ground observatories that are much bigger, but this would be a little bigger than a meter across. Okay, so let's see our activity. that shows you a shot of the data that we were looking at. So I think we can go to the screenshot. Yep. Now, I hope you notice, okay, we see stars, but it almost looks like we have dumbbells, right? There seems to be a star, a fairly bright star that somehow has connected to another blob that looks pretty similar. If you think those are the same, they are. Here's what's going on. The atmosphere overall is a great emitter of infrared. In fact, you are, I am. We emit infrared light. So there's a lot of noise when we look at an infrared source. So what you do is you look on the source first, and then you pivot, you move the telescope to look on what is hopefully just no signal, no star. And that helps you subtract the noise from the actual signal. These stars were in a fairly famous star-forming region, and I'll show you a picture of it in the infrared in our next shot. The overall area is called NGC 2264, and the area that we were photographing was kind of in the center there, just below the center where there are many sources. I should point out, we've talked about this before, that the funky name NGC 2264 suggests that this region is the 2,264th entry in the new general catalog. It helps you, just by that name, you can kind of look it up and find everything we know about that region. Now, an unexpected bonus is that I got to spend some time in the cockpit of a 747. This pilot here was, Jim was particularly happy to have company and tell us about his career path and how he got to be involved in NASA flights. It was great fun. And as I said, that was an unexpected bonus. I have to say that I've always had really bad eyesight, so I never imagined that I could become a pilot. But I must say that I got a little envious. I thought, well, that would be a cool career too. I also spent time with a flight engineer. This was Daryl, and we had a long conversation about how he got to get involved with NASA, and it was really nice to hear him talk about his grandfather, who had been a pilot in the Second World War, and how he spent some time in Italy. We were talking, and I said to Daryl, you know what, Daryl, how is it? How is it that you're not worried? You have so many instruments in front of you. How would we know that, there's a problem? I don't want to distract you. If you're supposed to be checking this, then, I'll let you kind of get on with it. And he said, oh, don't worry. If we have any kind of problem, this is going to light up like a Christmas tree. So I was reassured, and we carried on our conversation. Now, later on in the evening, when I was with the pilots looked kind of ahead, and they said, you know what? I think they're northern lights where we're going to be. And they got brighter and bigger, and I thought, oh, that's so cool. That is so cool. I'd never seen northern lights, anything like that. So I take my camera, my phone basically, and I take a picture, and this is what I got. Nothing, absolutely nothing. And I thought to myself, how could it possibly be that I can see so much beautiful light and my camera has nothing? Well, it turns out that I just needed some help. One of the pilots, just to stop me from complaining, gave me one of the night goggles that they had. They said, put the night goggles just against the window and put your camera against that. And this is what I got. Now, this is not a great picture to be sure, but it is mine, and I took it in the stratosphere. To help you guide your eye, I'm hoping you see kind of where the northern lights are compared to all the other infrared sources. The ground, even the airplane would glow in this light. Where it's most bright is, of course, where we got to see it mostly. But I found on the internet a picture that better captured what we could see with the naked eye. So it really, truly was breathtaking. And I urge you, if you ever have a chance to, if you hear that, oh, there's more northern light activity, try and check it out. You might not see something as impressive as this, but it really is cool. And there's many beautiful videos of the northern lights from the International Space Station. When our 12-hour shift ended, we landed, and I got to land in the cockpit of a 747. That was awesome. You're seeing here the sunrise is about to happen. It was about 6:30 in the morning. Please note that there's the moon and Venus as well, which I thought was a beautiful sign from the universe to wrap up this really exciting opportunity. And with that, I'd like to thank you so much for listening and allowing me to share this adventure with you. And I guess now we're gonna pick some of the many great questions that you had. So let's go ahead then.
All right, it's mailbag time. So here we go, Dr. Jean. Our first question is from Jessica. Is Venus the planet that we are seeing to the western sky shortly after sunset?
Great question, Jessica. When this question was asked, so earlier in our series, we did have Venus in the western sky, but now Venus is what we call a morning star, so it's up with the sun. I should point out that when you're looking in the sky and you see something really bright, it may or may not be a planet. After all, only Venus and Jupiter are really distinctly brighter than most things in the sky. Saturn, for example, or Mars could be confused with bright stars. So I would recommend looking it up. There are plenty of sites that will tell you what bright stars are visible and what planets are visible at any given time. Thank you for your question.
Great. Our next question is from Mackenzie. Why can we sometimes see the moon during the day?
This is probably, Mackenzie, one of the most common questions I get. So imagine that I'm the Earth, right? And my left fist is the sun. My right fist is going to be the moon, okay? So the moon goes around the sun. Think about this. The moon is going to spend half of its time in the direction where the sun is and half of its time away from the sun, which means that about 50% of the time, the moon is going to be close to the sun, and half the time, it's going to be up away when we have nighttime at our location. Now, the reason that we don't tend to notice the moon quite as much in the daytime is it's because it's competing with the sun. And also, if it's really close to the sun, we won't be able to see the moon at all because all we'll be able to see is its dark side. So look up during the day, and I think people will be surprised how often the moon is there. Thank you for that question.
All right, and our next question is from Camilla. Can you name a star?
So there are businesses that say, give us $50 and you can name a star, Sam or whatever else you want, Khadijah, whatever it is that you want. But that's not true, right? That's not true. If you would like to honor a friend of yours, you can print out your own little certificate and say, this star is going to be called Uncle Bob hereafter. But know that not all the libraries in the world, not all the websites are going to change the star's name to something that you choose.
Okay, and our next question is from Hunter. Could you stand on the stars? Why or why not?
I wouldn't recommend it, Hunter. Stars are really, really hot, right? So the sun's surface would be, when I say surface, I mean the outer parts of it would be about 6,000 degrees. So as you approached it, you get so hot, you would evaporate. You would turn into thin air, poof. So you wouldn't be able to even contemplate, should I stand on the sun or not?
Okay, our next question comes from Chloe and Carly. How many galaxies are there?
Thank you, Chloe and Carly, for this question. We have upped the number of galaxies. We think the number of galaxies in the universe is about 1 trillion. That is 1 with 12 zeros after it.
And Landon writes,
Hmm.
how many suns are there in the universe?
Okay, Landon. So think about, we have about 1 trillion galaxies. So that's 1 with 12 zeros following. There are about 200 billion stars in our galaxy. So if we assume that every galaxy has about as many stars as ours does, then we have to multiply 1 trillion by 200 billion, which means I need to have the number 2 and 12 zeros plus 11 zeros. That's 23 zeros. That is so large that I think it's useful to take some chalk or a pen and write down 23 zeros to kind of really contemplate how many stars. They might not look like the sun, but stars nonetheless, how many stars there are in the universe.
Okay, and Nicole writes, where does the stuff that gets sucked into a black hole go?
We don't know, Nicole. That's the fact of the matter. We don't know. But I'll tell you, I'm actually married to a black hole expert and who's a faculty at UWM. And he'll tell you that there are kind of two philosophies about this. One idea is that information is what we call is conserved. So if you send something into a black hole, in principle, it's possible to figure out what that was, what its mass was, you know, what information that thing carries. But the most common philosophy about what black holes do to things is that information is lost. In other words, if you put something into a black hole, there is no way, even in principle, to figure out what went in there. Good question. Maybe you can become, Nicole, a black hole expert and do some investigating in this topic as well.
Okay, and our next question is from Rebecca. Excuse me, what's the latest discovery that you have found interesting and why?
Well, I'd have to choose what's nearest and dearest to me, right? We have lots of discoveries, but this is the one that I think is most amazing because it touches me directly. In 2017, 2 neutron stars smashed into each other. Now, we knew this was a powerful event, and we had anticipated or predicted that this is the cause for these blasts of gamma rays that happen in all directions of the sky. But we could show that that was the case. So that 2 neutron stars make these tremendous bursts. Now, gamma rays, remember we talked about different kinds of flavors of light? And we had talked about visible light and infrared. Gamma rays are the most powerful kinds of light, and they carry so much energy that really it's hard to come up with a physics that could do that. And the first time I heard, oh, they could be, you know, neutron stars slamming together, it's like, yeah, really? That's pretty, you know, that's pretty imaginative thinking, but it is in fact true. There's more. The light that we saw was accompanied by gravitational waves. So this was measured by an instrument that Julian, my husband, is involved in. And in fact, some of the reasons why we moved was to follow this project along, which is why I'm saying it's near and dear to me. When 2 neutron stars collide, just like 2 black holes collide, they send ripples through space-time we call gravitational waves, and we can measure these gravitational waves even though this effect happened 100 million years ago in another galaxy. Think about that. we can actually measure things that had happened. We got a signal from both light and gravity for the first time simultaneously from outside our solar system. Whoa. And if that's not enough, there's more. When these two neutron stars collided, they sent a ripple of material and light through space, and we followed that glow for a while, and we noticed, wow, when these two neutron stars collide, they make gold. And that gold, so about a planet's worth of gold, that gold gets thrown into the galaxy, and stars pick up some of that, planets pick up of that, and some of that ends up in a wedding ring. Most of the gold on planet Earth came from two neutron stars colliding, and we saw the evidence of that. For all of those reasons, I think that might have been the most exciting scientific event in my lifetime. And there was quite a bit of, competition. There were other things that happened in my lifetime that were really cool too. But because this touches me personally, that's why I chose it.
Okay, and our next question from Carter, who is 6 years old and wants to know, what is a good telescope to buy?
You know what, Carter, for a person who is 6 and actually even older than that, I think the first instrument you want to buy is a good pair of binoculars. Binoculars don't need any kind of fancy setup. You can point up and you can look at things. The moon, of course, is always gratifying. You can look at Saturn's rings. You can look at the moons of Jupiter. In fact, you can see those tonight at around just after 10:30. They're going to start rising in the southeast. After you get familiar with how to find things with a telescope, then you might want to go to a star party and look at what people can see with their various telescopes. You can decide what kind of money you would like to invest. It's too bad when people buy a telescope quickly without doing a little bit of research, and then it sits in their garage. So I'd say start modestly, see what's available, figure out what you enjoy looking for, and then make your choice.
Great advice. All right, and our next question is from Creighton. Why can't you see the stars in the city?
It's a sad story, Creighton, isn't it? That we have so much what we call light pollution that it actually washes out the stars. And if you live in a really, really big city like New York City, it could be that you really can't see any stars other than 2 or 3, the very brightest ones, Jupiter. So you can be part of the solution. One of the things we can do is we can ask cities, please don't put lights without a lid, some kind of hat, if you will. That redirects light downward, and we're not just sending it out willy-nilly. If you have lights that you leave on to help your neighbors see, maybe for safety, try and make it so that they're always covered and they're pointing the light downward. Great, so please do your part.
And next we hear from Christine, who asks, where are some places to view the stars near Milwaukee?
Well, for starters, just go out, right? I say just go outside and look up. Sometimes you can see beautiful things. I was going for a walk last night and there was a beautiful crescent moon. You don't need to go very far. I think just looking up is the first step. You can improve, of course, if you move. Every time you move a little bit further outside the center of a city, you can do better. Obviously not towards Chicago. You would want to go north and west of town. One of my friends whisked me away from work one day and we went just off of a Brown Deer where they don't have street lights. And I'm pretty sure I got to see the Milky Way. Now, parks, of course, are great. I would suggest that you look first. Just make sure on the internet whether the park that's near you is open. There are also areas that are considered dark skies, and there's some north of in the state, in Door County. And if you want to go to someplace super duper dark, you can go to some of the areas in Colorado, I guess, are designated dark skies, and that's where you can do great astrophotography. The best dark sky I ever been on is on the top of Mauna Kea. And at that point, as a graduate student, I had never seen the Milky Way before. This was my first time, and it was breathtaking. So it is worthwhile looking for dark skies.
Okay, and Melissa wants to know, are there any known upcoming dates to see the maximum number of shooting stars?
This is a great plug, Melissa, because in August we have what we call the Perseids. So this is a meteor shower. They usually peak around the 11th and 12th of August. And the planetarium is going to have an online program called Shooting Stars and Meteor Showers, where we'll talk in more depth about what shooting stars are, how come we can predict when we'll have meteor showers. The Perseids are particularly good. You can sometimes have hundreds of shooting stars an hour. So I hope you can join us for that program.
Okay, and our last question for today, Dr. Jean, comes from Sophia, who wants to know, how can I become a scientist that studies stars and planets?
I'm so happy you're considering, Sophia, this. Well, for starters, sticking with it. Don't let anybody tell you that, oh, you can't do this and you can't do that. You can decide what you can do, right? Sticking with math, with science, enjoying it, embracing it. Just like anything, practice makes perfect. I would also say, try and solve, ask yourself questions. Imagine trying to answer problems that come up in everyday life, right? I'm building this Lego thing. How can I make it do this? Coding is important. I strongly urge you to learn how to program a computer. Computers don't always want to do what we want them to do, so it's good to train them. And online, you can learn how to program in something like Python, or even better, to learn some C programming language. I always advise people to master writing, just because astronomers have to spend a lot of time writing proposals to get data. Then you have to write papers about the results that you have. So being a good communicator, both in writing and orally, is a great skill. The other thing I would advise you is to learn another language if you don't know one already. English is a great language to speak with multiple people, and many scientists speak 2 languages. It's always a compliment when somebody is speaking your language to you, to be able to at least attempt to communicate in their language. It's a lovely compliment, and it's good for the brain. It makes you kind of connects your neurons in different ways. It also shows you that there are multiple ways of doing and saying things. I find that teamwork is important. All projects now are so big, it's not really possible to do something, a major discovery by yourself. So it's important to figure out, how can you work well with people? How can you inspire each other to come up with the best solutions to whatever problems you're trying to solve. So I wish you well in your endeavors to pursue a science career. And frankly, even if you pivoted at some point and you said, oh, I want to do something else, I don't want to become an astronomer, all the things I mentioned would be a great place to start for any career that you consider. And I guess with that, I think that's our final question. I'd like to thank you again so much for giving me an opportunity to share some of my passion about stars, about my adventure today on SOFIA. And I'd like to invite you, there'll be a message later on from me and the crew from the Alumni Association but I'd like to invite you again. Please ask questions, look for interesting things in the sky. Come visit us at the planetarium, either online or in person. And feel free to send an email to planetarium@uwm.edu if you have more questions that come up. I'd be very happy to chat with you again. Thank you very much.
And we're out.